In this video, we'll quickly do the concept of maxima and minima, and I must tell you that this particular tool is extensively used in physics, and therefore we'll be covering only those aspects of maxima and minima which we will require in understanding the fundamentals of physics. So let's get started. Well, in the previous two videos, we talked about differential calculus, we talked about rules and formulas, and we learned how to find out dy by dx if y as a function of x is given to us. But we did not talk about what is the physical significance of dy by dx. So let's talk about the physical significance of dy by dx, and let's imagine that this is your y-axis and this is the x-axis, and y is related with x in such a manner that the graph of y as a function of x comes out to be like this. And let's consider any point on this graph whose coordinate is x comma y. Now what is dy? It is the little change in y, that is infinitely small change in y. Why we are getting infinitely small change in y? Because we are changing x by very small amount. So if we change the value of x by a very small amount, I'm denoting it by this little line. Well, this line is infinitely small, but I'm showing it finite in order to visualize it, right? So if this is little change in x, then corresponding to it, this is going to be little change in y. So if I just magnify it, this is going to be like this. This is your dx and this is your dy. So what is meant by dy by dx? Then if you just join these 2 points, then this angle theta, then dy by dx is nothing but tan of this angle theta. And therefore, we can actually say that dy by dx is nothing but it is a slope of this particular line. Now, what is this particular line? Well, this particular line is going to be the tangent at x comma y, because this line is going to make angle theta with the positive x-axis. So this is how we got the physical significance of dy by dx, that dy by dx at any point x comma y in a function y as a function of x is going to be equal to the slope of y equal to f of x graph. At which point? At x comma y. So now we know that if dy by dx is more, slope is going to be more. If dy by dx is less, slope is going to be less. And this dy by dx is going to be another function, which may be a constant function, which may be a linear function, which may be any sort of function, right? So if this dy by dx comes out to be a constant function, then in that case we can say that the slope is not changing. For example, if y is a function of x is a linear function, and if we differentiate it, then dy by dx is going to be a constant function. And if y is a function of x is a quadratic function, then if we differentiate it, dy by dx is going to be a linear function. That means slope is going to change linearly with x. And in fact, we can have a look at these two types of functions. As I said, if y is a linear function, that means y equal to mx plus c, and if you try to differentiate it, dy by dx, it is going to be equal to m. You can see that this dy by dx is coming out to be constant. What does it mean? It means that the slope of y equal to mx plus c is constant, which we already know. And let's take another example, y equal to ax square plus bx plus c. Then in this case, if you try to differentiate it, dy by dx, it is going to be equal to 2ax plus b. So you can see that this dy by dx is another function, and it is linearly changing with respect to x. That's why we can say that the slope of a quadratic function or a parabola, it changes linearly with respect to x. And in fact, we have noted this point when we studied quadratic function. And one more thing we can note over here, that if dy by dx is greater than 0, it implies that graph is increasing, because we have already talked about the slope, that if slope is positive, graph is increasing. So we can write that if dy by dx is greater than 0, this implies that it is going to be an increasing graph. And if dy by dx is negative, what does it mean? It is going to be that the graph is decreasing. And what will happen if dy by dx is equal to 0? If dy by dx is equal to 0, it means that the slope is 0, and if dy by dx is 0 for all values of x, it means that the graph is going to be constant, it is not changing at all. So this is the significance of dy by dx. Next we will talk about what is the significance of d2y by dx2, that is a double derivative of y with respect to x. So this d2y by dx2, basically it tells us about the concavity of the graph of y equal to f of x. Obviously we will not talk in terms of a linear function or constant function, because in terms of linear or constant function this d2y by dx2 is going to be 0. So we can say that if d2y by dx2 is equal to 0, this implies that the graph is either constant or it's a straight line graph. However, in case of a non-linear function, the graph is going to be a curve, and whether that curve is going to be concave up or it is going to be concave down, the concavity of that curve is basically decided by this d2y by dx2. So if at any point this d2y by dx2 is greater than 0, let's say, then it implies that the graph is concave up. And if this d2y by dx2 is less than 0, and if it is negative, it implies that the graph is concave down. So this is the physical significance of d2y by dx2. Now let's talk about the mathematical condition for maxima and minima, and in fact what is meant by maxima and minima. So if we now look at this particular graph, then we can see that the maximum value of y is going to be positive infinity and the minimum value of y is going to be minus infinity. However, we're not talking about the maximum and minimum value of y. We are here talking about the maxima and minima, or simply local maxima and local minima. What is meant by local maxima? Well, if you consider this particular point over here, this point is basically the local maxima. Why? Because if you look at the nearby values of y in comparison to that, this value of y is maximum, and therefore this point is called as point of local maxima. And now if you look at this particular point, this point is going to be local minima. Why? Because if you compare the value of y from its neighborhood, the value of y at this particular point is going to be minimum, and therefore this point is called as point of local minima. Now at times we know the equation of y as a function of x, and we have to find out the coordinates of this local maxima and local minima. How we are going to do that? But basically we have to find out the value of x at which y is going to have a local maxima, and corresponding to it we can find out the value of y at that value of x, and similarly we will do it for finding local minima. And definitely in order to do that, we will require the condition of local maxima and local minima, or the condition of maxima and minima. So let's try to have a look at the mathematical condition of maxima and minima. Well, the first thing that you will observe is that at both of these 2 points, the slope is going to be 0, because if you draw a tangent, the tangent at these 2 points, it is going to be parallel to x-axis. Therefore, the first condition we can write that it is going to be dy by dx is going to be 0 at maxima, as well as dy by dx is going to be 0 at minima. Now what will be the another condition which is going to differentiate between the two? Because in both the cases dy by dx is coming out to be 0. You can see that in case of local maxima the graph is concave down, and in case of local minima the graph is concave up. And we know that the concavity is decided by double derivative of the graph. And since it is concave down at local maxima, so we can say that double derivative is going to be negative. So we can write this over here, that d2y by dx2 is going to be less than 0. And in case of minima, d2y by dx2 is going to be greater than 0. So how you are going to find the value of local maxima and local minima? The first thing that you will do, if you have a y as a function of x, you will differentiate it and you will find f prime x, and then you will equate it to 0. And when you equate it to 0, you are going to get the values of x for which the slope is going to be 0, and the values of x for which the slope is 0 are those values of x for which the graph is going to have either local maxima or local minima. Now you want to check whether there is local maxima or local minima for the values of x which we got by equating the first derivative to 0. For that we have to find out the double derivative of y as a function of x, and we have to put the value of x in that double derivative. If it comes out to be negative, it means the value of x for which the slope was 0 was the point of maxima, and if it comes out to be greater than 0, that means the value of x for which the slope comes out to be 0 is going to have the point of local minima. So how we are going to find the points of local maxima and local minima by using these mathematical conditions? Let's write down the steps. So let's imagine that we have a function y equal to f of x. This can be, as I said, any type of function. It can be quadratic function, it can be 3-degree function, it can be 4-degree function. So it can be just any function, it can be sinusoidal function or whatever it can be. Now, how to find out the point of local maxima or minima? The first thing that we will do is to differentiate this y with respect to x. So dy by dx will be equal to f prime x. The second step that we will do over here, you will find d2y by dx2, which will be your f double prime x. Now the third step would be to finding the value of x for which dy by dx is going to be 0. That means you will equate f prime x with 0. So when you do it, let's imagine you are going to get three values of x. Well, it is possible to have only one value of x. It is possible to have only two values of x. It is possible to have more than two values of x. So let's say you get three values of x for which this first derivative is 0. It is x1, x2 and x3. Now we just need to find out whether at x1 there will be maxima or minima, whether at x2 it will be maxima or minima, or at x3 whether it will be maxima or minima. For that we are going to use this f double prime x. So how we are going to do it? The fourth step is going to be, we are going to find out f double prime of x1. We will find out f double prime of x2. We will find out f double prime of x3. That means from the step 2, whatever function we got, we just need to put the values of x1, x2 and x3 likewise, and we just need to check whether it is coming out to be positive or negative, positive or negative, positive or negative. So if it comes out to be positive, then it means that corresponding to value of x1 there was a minima, and if it comes out to be negative, it means that corresponding to that value of x there is a maxima. So we got the values of x for which whether there are maxima or minima, it depends upon what we are looking for. Either we are looking for the points of maxima or points of minima. Now we got the x coordinate. How to get the y coordinate? Well, we just need to put the value of x in the original function, that is y equal to f of x, and corresponding to x1 we will get y1, corresponding to x2 we will get y2, corresponding to x3 we are going to get y3. So in this manner you can find out the coordinates of local maxima and local minima. Let's now see how we can find maxima and minima of a quadratic function. So let's imagine that we have a function f of x which is equal to ax square plus bx plus c. So it is a quadratic function. In fact, we have done this part in the quadratic function video as well. We are going to repeat it over here. So there will be two possibilities if a is greater than 0 and if a is less than 0. We know that if a is greater than 0, then the graph is going to be concave up. That means there will be no maxima, but there will be a minima. In fact, that is going to be the minimum value of the graph. So where it is going to be? It is going to be at x equal to minus b by 2a. So at x equal to minus b by 2a, you are going to find one minima. And if a is less than 0, then the graph is going to be concave down, and therefore we are going to have a maximum value of the graph. That will be at again x equal to minus of b by 2a. So there will be a maxima at x equal to minus of b by 2a. So we can memorize these results. Finally, what will be the maximum value of the function when it is the addition of two sinusoidal function? What are sinusoidal function? Well, the sine function and cosine function, they are called as sinusoidal function. So if we have sine function alone, it is easy to find its maximum value, because the maximum value of a sine x is going to be a and minimum value will be minus a. Similarly, maximum value of b cos x will be b and minimum value will be minus b. But when they are added together, what will be the maximum value of y? Because if x increases, a sin x will increase, whereas b cos x is going to decrease. So we don't require at what value of x y is going to be maximum or minimum. Generally we require what will be the maximum value of y and what will be the minimum value of y. So we can memorize it that The maximum value of y is equal to under root of a square plus b square, and the minimum value of y will be equal to under root of a square plus b square but negative. So this a can be positive or negative, this b can be positive or negative. In all the cases, the maximum value of y will be given by this expression and minimum value of y will be given by this expression. Well, this is all in the maxima and minima. And if you want to solve problems specifically related to this topic only, and you do not want to waste time in finding problems in the books or otherwise, then you can download my application whose link is provided in the description box below. Thanks for watching.